Welcome all. We can already started elementary quantum mechanics. ठीक है, उसके आगे का जो पार्ट है आज अपने को जो देखना है वो है कॉम्पटाउन इफेक्ट. Understand? This is the diagram of that Compton effect. This is electron, target electron at rest, and this is nothing but the incident photon. ये इंसिडेंट फोटोन है, उसकी जो एनर्जी रहेगी E is equal to h mu. तो when when the photon strikes on an electron at rest, electron rest position पर है. When the photon strikes on electron at rest, then what happens? So this photon will transfer its kinetic energy and momentum to the electron, and therefore the scattered photon, this is the scattered photon. Therefore, what happens? This scattered photon will have lower energy than incident photon, and its energy divided by E is equal to h mu dash. Understand? So scattered photon will having lower energy than incident photon. Here, this angle is nothing but the theta. This angle is nothing but the phi. This is nothing but the recoil electron. ये जो रहेगा ये क्या है? Recoil electron रहेगा. And this is nothing but the theta, and this is the phi angle. Angle of scattered photon and the ejected electron. ये angle of ejected electron रहेगा, और ये angle of we can say the phi is nothing but the angle of the scattered photon. So Compton, AH Compton, he can observe this effect in 1923. So H Compton, AH Compton scientist name, scientist का नाम है Compton. So this Compton investigated the scattering of X-ray by crystals. अगर एक्सरे अगर क्रिस्टल पर जाकर गिरते हैं तो क्या हो जाता है? Scattering will be take place. Understand? And he found that, and Compton found that the wavelength of the scattered radiation is greater than the wavelength of incident radiation. Scattered जो radiation है उनकी जो wavelength रहेगी वो ज्यादा रहेगी than wavelength of incident radiation. Understand? Compton investigated the scattering of X-rays by crystals. For example, graphite. अगर एक्सरे क्रिस्टल पर जाकर गिरते हैं तो क्या होने वाला है? Scattering will be take place. Understand? So Compton observed that the wavelength of the scattered radiation is greater than the wavelength of incident radiations. The observed change in wavelength of the scattered radiation is found to be independent of the wavelength of incident radiation. ये जो observed change है in wavelength, यानी कि wavelength of scattered radiation कैसी रहेंगी? ज्यादा रहेंगी than incident radiations. So the observed change in wavelength of the scattered radiation is found to be independent of the wavelength of incident radiations. देखिए जो कुछ भी observed change in wavelength है तो ये independent रहेगा, depending रहेगा काय पर? Incident radiation, wavelength of incident radiations. So this change in wavelength or frequency of the scattered radiation is known as Compton effect. ठीक है? This change in wavelength or frequency of the scattered radiation is known as Compton effect. So this Compton investigated the scattering of X-rays by crystals and found that wavelength of scattered radiation is greater than wavelength of incident radiation. Scattered radiation की wavelength ये incident radiation से ज़्यादा रहेंगी. The observed change in wavelength of the scattered radiation is found to be independent of wavelength of incident radiation. कि जो कुछ भी observed change है wavelength में of the scattered radiation, it is independent of wavelength of the incident radiations. तो दिस चेंज इन वेवलेंथ or frequency of the scattered radiation is known as Compton effect. इसको ही क्या कहते हैं? Compton effect ऐसा कहते हैं. ठीक है. So when a photon strikes on an electron at rest, the photon will transfer its kinetic energy and momentum to the electron, and therefore the scattered photon will have lower energy than incident photon. See this diagram. In this diagram, electron is at rest position. Electron ये rest position में है, जिसको अपन कहते हैं target electron at rest. And what happens? This is nothing but the photon. ये incident photon है. तो ये photon क्या होता है? This photon भी strikes on an electron. इलेक्ट्रॉन जो रेस्ट पोजीशन में उस पर जाकर गिरता है, तो क्या हो जाएगा फिर? जो इलेक्ट्रॉन रेस्ट पोजीशन में है और उस पर अगर ये फोटोन गिर जाता है, तो दिस इज नथिंग बट व्हाट हैपेंस? दिस इंसिडेंट फोटोन बी स्कैटर्ड. इंसिडेंट फोटोन स्कैटर्ड हो गया, और जो इलेक्ट्रॉन रेस्ट है वो रेस्ट पोजीशन में नहीं रहेगा, तो देयरफॉर यू कैन गेट दिस रिकॉइल इलेक्ट्रॉन. अंडरस्टैंड? एंड दिस इज नथिंग बट दैट थीटा जो रहेगा, it is nothing but the angle of ejected electron, theta, and this symbol is nothing but the phi. It is the angle of the scattered photon. ठीक है. तो when a photon, जिसको एनर्जी है E is equal to h mu, when a photon strikes on electron at rest, the photon will strikes on the electron at rest, then what happens? This photon will transfer its kinetic energy and momentum to the electron. Photon will transfer its kinetic energy and momentum to the electron, which is at rest, and therefore this scattered photon will have lower energy than the incident photon. Understand? This is the reason that scattered photon is having the lower energy than incident photon, because this photon, incident photon, it can transfer its kinetic energy and momentum to the electron, and therefore the scattered photon will have lower energy than the incident photon. Its energy is equal to h mu dash. So let a photon of energy h mu collides with the electron at rest, mass m0. Then after collision, the scattered photon will having the energy h mu dash. Here this theta is nothing but the angle of the ejected electron, or we can say that recoil electron, and this phi, the symbol phi, is nothing but the angle of the scattered photon. Phi is nothing but the angle of the scattered photon with the direction of incident photon, with the direction of, this is nothing but the direction of incident photon, with the direction of incident photon. So this change in wavelength due to scattering will be, so actually it is observed that the scattered wavelength is always greater than the incident wavelength. Scattered जो wavelength रहेंगी, it is greater than the incident wavelength. ठीक है. देखो कॉम्पटन ने जो कहा था, Compton is saying same thing. Compton investigated the scattering of X-rays by crystals and found that the wavelength of scattered radiation is greater than the wavelength of incident radiation. So it is right. And the observed change in wavelength of the scattered radiation is found to be independent of the wavelength of incident radiations. So this change in wavelength or frequency of scattered radiation is known as Compton effect, and this is shown by this diagram. Compton effect is shown by this diagram. So we can already see that electron is at rest position, electron is rest position में रहेगा, and this we can that photon will strikes on an electron at rest. So what happens? This photon will transfer its kinetic energy and momentum to the electron, and that's why the scattered photon will have lower energy than incident photon. इसलिए ये जो scattered photon जो रहेंगे, इसकी एनर्जी कैसी रहती है? इंसिडेंट जो फोटोन रहता है उससे कम रहती है, क्योंकि इंसिडेंट फोटोन क्या करता है, इसकी जो एनर्जी, काइनेटिक एनर्जी और मोमेंटम है, ये क्या करता है, कैन ट्रांसफर काइनेटिक एनर्जी मोमेंटम टू द इलेक्ट्रॉन। ठीक है, तो जब ये फोटोन इलेक्ट्रॉन पर जाकर गिरेगा, देन व्हाट हैपेंस, तो बोथ विल चेंज देयर डायरेक्शन, यानी कि इंसिडेंट जो फोटोन रहेगा वो भी इसकी डायरेक्शन चेंज किया, यू कैन गेट हियर दिस स्कैटर्ड फोटोन। और ये इलेक्ट्रॉन जो रेस्ट है, ये भी क्या हो जाएगा, इधर चले गया, दैट्स व्हाई यू कैन से दैट रिकॉइल इलेक्ट्रॉन, और इसका अपन कहते हैं इजेक्टेड इलेक्ट्रॉन। ठीक है, तो कितने डायरेक्शन में, कि कितने एंगल में उसका ट्रांसफर हो गया, तो दिस इज नथिंग बट द थीटा, ये थीटा जो है, इट इज नथिंग बट द एंगल ऑफ द इजेक्टेड इलेक्ट्रॉन। और ये जो फाई जो है, इट इज नथिंग बट द वी कैन से दैट एंगल ऑफ द स्कैटर्ड फोटोन, एंगल ऑफ द स्कैटर्ड फोटोन रहेगा। ठीक है, तो here we can say that the change in wavelength, the change in wavelength due to scattering, understand, due to scattering what happens here, wavelength is change, है ना, wavelength में क्या हो गया है, चेंज हो गया, क्योंकि scattered wavelength जो रहेंगी, it is always greater than incident wavelength, scattered जो wavelength रहती है incident wavelength से ज्यादा रहती है। तो change in wavelength due to scattering, it is can be determined by del lambda, lambda is nothing but wavelength, तो डेल लैम्डा यानी कि क्या रहेगा, इज चेंज इन वेवलेंथ, बट डेल लैम्डा इज नोन एज द कॉम्पटन शिफ्ट, इसको क्या कहते हैं, कॉम्पटन शिफ्ट ऐसे कहते हैं, इज इक्वल टू लैम्डा डैश माइनस लैम्डा, लैम्डा यानी कि वेवलेंथ, तो ये डैश जो रहेगा ये क्या के लिए रहेगा, स्कैटर्ड फोटोन जो है, स्कैटर्ड फोटोन है ना, ये डायग्राम में जो आपने बताया है स्कैटर्ड फोटोन, ठीक है, दिस उसके लिए रहेगा। और लैम्डा जो रहेगा ये इंसिडेंट के लिए, इंसिडेंट फोटोन जो रहेंगे उसकी वेवलेंथ रहेगी लैम्डा। ठीक है, तो वी ऑलरेडी नो दैट कि इंसिडेंट फोटोन विल स्ट्राइक ऑन द इलेक्ट्रॉन एट रेस्ट, so we can get here the scattered photon, but its energy will be lower, or its energy will be nothing but E is equal to h mu dash, so that's why that scattered wavelength जो रहेंगी, it is always greater than the incident wavelength, scattered जो wavelength रहती है इंसिडेंट वेवलेंथ से कैसे रहती है, कभी भी ज्यादा रहती है, बट we can already say that the scattered photon will be having the lower energy than the incident photon, but scattered जो photon रहती है उनकी लेकिन एनर्जी कम रहेगी, बिकॉज दिस फोटोन, ये जो फोटोन है ये क्या करता है, इसकी काइनेटिक एनर्जी और मोमेंटम ये इलेक्ट्रॉन को ट्रांसफर कर देता है, and that's why scattered photon is having lower energy than incident photon, but scattered wavelength is always greater than incident wavelength, लेकिन scattered जो wavelength रहती है ये incident wavelength से लेकिन कैसी रहती है, ज्यादा रहती है। ओके, the change in wavelength due to scattering can be determined by del lambda is equal to lambda dash minus lambda is equal to h upon m0c in bracket 1 minus cos theta. So here del lambda is called Compton shift. Thus, the scattered wavelength is always greater than incident wavelength. The scattered wavelength is always greater than incident wavelength. This is complete about Compton effect. ये पूरा जो है ये Compton effect के बारे में है। The question will be asked for 5 marks. Write short notes on Compton effect. या फिर लॉन्ग आंसर के लिए भी क्वेश्चन आता है, एक्सप्लेन Compton effect. So first you can draw the diagram, then you can give this explanation that Compton investigated the scattering of X-rays by crystals, for example graphite, and found that wavelength of the scattered radiation is greater than the wavelength of incident radiation. ठीक है, यानी कॉम्पटन ने जो ऑब्जर्व किया है कि अगर एक्सरे अगर ग्राफाइट पर गिरते हैं तो क्या होता है, तो he can observe that the wavelength of the scattered radiation is greater than the wavelength of incident radiation, and the observed change in wavelength of the scattered radiation is found to be independent of the wavelength of incident radiation.